Let's look at this question. If a coin is biased such that when it is flipped 6 times, the probability of 4 heads, this should say 4 heads and 2 tails turning up is 4 times the probability of 2 heads and 4 tails coming up, not fails, tails coming up. Find the probability of an equal number of heads and tails turning up when the coin is flipped 4 times. Okay, so let the probability of getting a head be equal to n. So probability of getting a tail would be equal to 1 minus n. So 4 heads and 2 tails would be given by 6c4 n raised to the power 4 and 1 minus n raised to the power 2, and this is equal to 4 times the probability of 2 heads. So 6c2 into n square into 1 minus n raised to the power 4. Okay, 64 is equal to 62, so I can cancel it out straight away. N raised to power 4, n square, so I can cancel n square. This will turn into n square. I can also cancel out 1 minus n square, and this will turn to square. So now I have n square is equal to 4 plus 4n square minus 8n, or 3n square minus 8n plus 4 is equal to 0. So middle term splitting, 6 and 2 work. So 3n square minus 6n minus 2n plus 4 is equal to 0. Taking 3n common, n minus 2 minus 2, n minus 2 is equal to 0, or n is equal to 2 or 2 by 3. Now because we are dealing with probability, n cannot be greater than 1, so this value is rejected. So the probability of getting heads is 2 by 3, probability of getting tails is 1 by 3. Finally, they asked me find the probability of an equal number of heads and tails turning up when the coin is flipped 4 times. So 4c2 into 2 by 3 whole square into 1 by 3 whole square is what we are dealing with. So 6 into 4 divided by 81, 2 times, 27 times. Final answer should be 8 by 27, or option A.